we as teachers, we're not perfect, right?
No,
we
we're
go
not. We're
in
just as
and,
human as the kids are, and the kids need to know that.
Yeah. And I think that connection to the students is important. Now, you get that connection to the students is important. They see that you're human. But then they also need to see how their subject is connected. They need to see, if I'm teaching science, why do I need to know this? Why do I need to know about osmosis? Why do I need to know about photosynthesis? Why do I need to know these things? And I think in a science realm, it's oftentimes easy to take a student to say, why do I need to know about photosynthesis? And then you then have this discussion about carbon dioxide and oxygen, the fact that we really can't live unless we have these here plants that can
Yeah.
take in the energy of the sun and the water in the ground and then take in our carbon dioxide and produce the oxygen that we need to breathe.
And that it's a give and take.
Yeah.
Because our carbon dioxide that we put out helps them
It's
live.
a symbiotic relationship. We can't survive without the other. And you get into these, but then you get into, as a science teacher, you can now progress to kind of rates and proportions, the way I see it. Because I come from a math background. I see that science topic, and then I see how does that relate to mathematics. Well, it relates to these kind of ecosystem type modeling, to where if you have too much of this versus too much of that, and then and the imbalance, and that's all mathematical modeling. That's looking at proportions, percentages, ratios.
See, to me, that speaks to homeostasis.
That,
I'm a science background.
right, okay. And that's...
What?
You just crack me up.
But that's where this integration, I believe, if you can get that other teacher on board. If you're the science teacher, you can get that math teacher on board. If you're the math teacher, you get that science teacher on board. Then the integration can be that much better. That integration can go farther than what you could do on your own.
Mm-hmm.
Me, on my own, I take a small concept of science. Like right now, I'm writing a paper on an activity I've done with friction. I've done with friction. But you have this concept that I go to the Children's Museum, kids are rolling golf balls on this ramp. It's called the Big U, and the ball dies. Why does it die? You know, it's because of friction. So it doesn't return to the same height that it was on the right side, you know, when you release it and goes to the left. Well, why is that? You have this simple elementary concept of friction. Well, let's model that. And it goes into, I then go into, well, it's oscillatory motion. It's a periodic wave function that actually dampens. And then you can create a function, a damping sinusoidal function that actually shows when that ball is going to stop. And then you can increase that graph or that curve and then predict at what point in time, given the initial height, what time it's going to die out, dampen. And that's what I see. And so I go into this elementary kind of children's museum type environment, and I see the science concept, and then I go right to the mathematics that I know.
Mm-hmm.
Whereas maybe the science person didn't know that. And then I go and I look at physics textbooks, and then they briefly address this. And they talk about damping function. They typically just address the exponential decay. But there's so many other ways to dampen a function. To me, I see all of this that could be taught and could be explored on a mathematical component. But if I go and I talk with a physics teacher, when I go and I talk to the physics professor, I go and I talk to a science professor, or go and talk to somebody that has that knowledge about that content, the science, the other content, I gain that much more. I gain that much more knowledge of it, so that when I'm talking to my students and they're doing this in a mathematics classroom, I can then see how it's connected. I can then see how computer engineers, when they're wanting to fade out sound waves, they apply a damping function, whether it's a linear damping function, or it's a logarithmic damping function, or it's an exponential damping function, and it is a function that they program into the computer that actually takes from this time stamp of the sound and then damps it all down. And then in your car, you hit a bump, your spring starts bouncing up. That spring would keep going on and on and keep oscillating back and forth, back and forth, back and forth. But you can apply a strut. I think it's called a strut. Now I'm lack of knowledge. But you can apply a damping kind of what is it called? There goes my
I won't know it
mechanics.
if you say it.
But
so-
anyway, it makes that oscillation damp out faster. So that when you hit the bump, it bounces, but then it quickly compresses down to the equilibrium.
Are you talking about shocks or struts?
Yeah,
They're like the same thing.
Shocks and struts, and it's kind of I've looked under a car once or twice in my life. Not that man
Not
that's
all
all
of
mechanical, but you have a spring,
Mhm.
and then you have these long bars, if you will. What are those things called?
Those are your,
The axle?
no.
No. But you know what I'm talking about, and that dampens out the
What was the one
oscillation.
I said? Not strut, but
Shocks.
shocks. Those are your
Okay,
shocks.
those are your shocks.
Yes.
And the
I
shocks,
don't know anything about
the
cars.
shocks dampen out
Uh-huh.
the oscillation of the spring. And so when you hit a bump, you don't feel it. The spring compresses up, but instead of your wheel just now vibrating back and back and back and back, it has something that dampens that out
You're
quickly.
such a teacher.
Well, but I learned that because
No, I mean it's really neat to hear you talk because you are such a teacher.
what? Yeah, thanks.
Because we were talking about
Emily's
integration.
rolling her eyes. She
Well,
knows. She
I was
knows.
like,
She,
Wait a
and then you
minute.
started giving examples of how to integrate math and science, and then you like shot off on this
tangent.
explanation.
Yeah, a teachable moment, I guess.
Yeah, there you go. There you go. Because I didn't know there was a way to predict how long a thing would go back and forth
Yeah.
before it stopped.
Yeah.
I'm not mathy at all. That's why I'm in you teach, because I didn't have to do math and science. No offense.
That's fine. It's fine. Do you have math teachers do the same thing? You know?
Oh yeah. Oh yeah.
And
Our physics teacher
There's
was
a
trying to
whole lot
explain
more.
chemistry to us, and we just kind of looked at him funny.
I was like, don't explain chemistry to me.
now,
Yeah.
I believe there is a definite need that we don't need to. I don't believe we need to produce fully all-knowing. Like if you say, all right, I now need to be a high school teacher to know all of the physics and the chemistry and the biology and the science in addition to the mathematics in order to be a teacher that does, integration, I would now limit my knowledge on all those subject areas and just learn enough to be able to get by. I think it's excellent that when you progress in education, you have these experts in the field. You have these, in your middle school, you have the math people that know a lot about the math. You have the science people that know a lot about the science. It is the connection between the two. It is bringing the teachers together. It's having the teachers question their own and how I can connect it, and then going down and say, look, you don't have to do this project with me, but help me out. I need knowledge about, am I saying it right? Am I going to be presenting it correctly to the students? I did another prediction of the presidential election, and I went to the social studies teachers to say, help me out with electoral college. Do I have it correct? Do I know how all this works out so that when I'm telling them to go to the polls and see how the polls and then predict what the electoral vote's going to be in each state and how it's broken down, does every state, all electoral votes go? No, it's not. You have states like Nebraska that broke off. They didn't have all their electors vote for the same president. So the state went one way, but all but one district voted that way, and the other one voted away. So electoral votes don't have to go just by the popular
I did not know
vote.
that.
Yeah, and so
I thought like all the votes for a state had to go to one.
no, they don't have. The electors in the electoral college can vote how they want. They just typically go with the popular vote of their state, but it doesn't have to go that way. And so now I can show that to my students, so when they go and they research, they can say, well, look, poll data shows the state's going to go that way, but look at the history of the state. Do they always vote along the lines of what their state does? And so when they do that, they now, when they're collecting the data, they have background of what the data is telling them, and then when they force it to go this way or that way in their modeling and in the statistics, they have better confidence in how their graphs are doing the prediction. Is this really going to be, do the poles fluctuate? Do they oscillate? Do I need to model it with a sine function? Or is it more linear? Do I need to model
Does
it
it
with a
need
line?
shocks?
Does it need shocks or struts and all that kind of stuff? Yes.
Making connections.
I gotcha.
No, but and so you have all of that, and then in this same article I read, they talked about what we've talked about in class, covering the standards. This idea of time, right?
Mm-hmm.
When you can you integrate and still cover the standards you need to cover? And this is across the board. This is at the elementary level, middle school, high school level.
Everybody's doing integration, though. Sure you can. That
Well,
makes it easy.
That's a good argument. If everybody's doing it, then it wouldn't be so foreign, and then it maybe could be done, and you could see
well,
how
and
it
then, like,
connects.
if there's, like, say, a topic that you aren't able to get into as much in your science classroom because you're trying to pull in social studies or whatever, then, like, you might say to this math teacher, oh, well, hey, while you're doing percentages and stuff, can you cover, what is it, homeostasis for me?
Okay.
Or something like that. And teachers need to communicate and realize they're a team working together, like, in their individual classrooms. But
Yes. It's
I work at a
communication.
summer
It comes
camp,
down to communication.
and like all of us counselors are doing the same thing in different cabins, but we're working as a whole team together, and like building up that team mentality within a community of teachers at any school is like vital.
Well, Lindell, my mom's a sophomore English teacher at Lindell, and I know she was talking the other day about teaming with the history teacher because they're trying to cover, I don't know if this is what it was, but like one of the wars. So he said, hey, I know y'all are about to read a novel. What about this? And so she's reading this history-based novel, and then the kids are going to report on it, and that way they're learning it here and here.
Yep.
And so I thought that was cool. That was like the first time I'd heard about it, because I know when I was in school, that was not the case. Like, yeah, your math and science kind of went together a little, but it was math in the science, but it
And
never...
like when history and English teachers team up and like you read a history book for English class, it makes it so much easier on the students too, because then they're not having to read this novel for history
and
this novel for English.
Yeah.
It just, you kill two birds with one stone.
Well, and
it
it's
makes it a
more
lot easier on
interesting than the textbook. I mean,
Right?
they're getting, especially if it's like a real like account of, what they're learning about. I would be more interested in that than sitting there reading about it in a textbook. In yada yada yada, this person did this. Why don't you tell me, like, from his point of view?
Yeah.
I was standing on the lines and or whatever. Because to me that's interesting, but reading a textbook I could care less.
Tell me this. You bring up... most people see math, science going together. English, social studies going together. Is there a way to put them together?
Yeah.
Read a science book in English class.
Okay.
Well, Amy found a book in the bookstore which was bringing English and math.
Yeah.
And it was reading a book about, I think it was dragons. Like, it was like a younger one, but then they had all these like mathematical equations like fit in there, and then at the end of the chapter it asked a question. So then, it's like bringing
And I think it's
polar
important
opposites.
too to like in math and science to bring in like those like public speaking skills. Because if it all makes sense in here and you can't make it come out here, you've got
That's
a problem.
True. That's true.
And so teaching the kids young how to talk through a math problem in a coherent way is, getting those public speaking
instead
skills
of this
in there.
goes to this and then it makes this. And then
No,
it goes,
what goes to what makes what, and what does goes to mean, and what does makes mean.
no,
What is
that's what
this?
students do. is they
Earlier in the day,
this.
this was this, but now this is that.
But teaching them how to use coherent terms that if you close your eyes and listen, you still understand.
Yeah,
Mm-hmm.
I like
I
that.
think that's really important. And in science, too, to help them, if they understand it but they can't say it,
Yeah.
then it's not going to do them a whole lot of good.
There's a...
And writing, too, heck. If you can write the explanation to how to solve a math problem, you understand that math problem.
You get into the communication. Communication is, in mathematics, is called a process standard. And it's same in science. It's this idea of you have the knowledge, now you need to communicate it. When you look at Bloom's taxonomy, you have this idea of comprehension and putting things into your own words. And synthesis, to where you're taking multiple areas and then you're compiling it in a way to where you see the connections between them all, and you can communicate that outward. I've done some stuff with graduate students, and I got a couple teachers over at the Innovation Academy that have integrated literature into math and science. And we started off looking at Around the World in 80 Days. And so we read this book, and then you're reading it for all 4 content areas. Each chapter that you're reading, you're seeing math, science, social studies, language arts, and you're seeing how it's all connected. And so you have math teachers and science teachers that are really finding that math science. Boy, they see it, or they can see its expansion into the classroom. And then you have the English social studies that Some do a real good job, but it's hard to see where that math and science, or they look at just the face value of the math. You know, he's traveling, so we need to find out how far he traveled. Distance is one thing, but then you have distance, you have rate, you have the route that he went, you have plotting coordinates, you have latitude, longitude. Then you can go in rates of change versus this automobile or this machine that was available at that time versus this machine, and then choosing, do I go on this boat or that boat? Do I use, you know, what is a sledge, if you will, and it's a science concept, and then reading in the literature, the book describes what the sledge is. Well, can you take that and then construct it? And then how does that connect to what we have now in traveling? And so going through a piece of literature right there can integrate all 4 subject areas. And you could be a math teacher just doing it. You could be a science teacher just doing it, an English teacher just doing it. But if you had teachers that got together and took that same piece of literature and integrated it across, then the student would not be as burdened with all the reading materials, and the student would know that, you know, I got to read Jules Verne this week. Why? Because my English teacher wants me to read it, my social studies teacher wants me to read it, my math teacher wants me to read it, my science teacher wants me to read it.
And I think that creates so much, like, when you have, like you said, your math teacher wants you to read this novel for his class and these other classes.
It's almost like accountability, because if you don't have it for one class, you are darn not going to have it for the other 3. And so you know you're going to get in trouble or get behind or whatever.
And I think, too, that especially when the material's reading, it creates a value to reading to the kids that like the kids that perform in math class and slack in English. It's going to create a lot more, what's the word? Desirability to get that done, especially like you say, you have a lot of respect for that math teacher, and the English teacher drives you nuts. It's going to make it a lot more appealing to do the work and then have it apply to all these different classes. I think that's really cool.
Right.
Hi, Devin.
Hi. I'm completing a thought right now, so
Okay.
I'm not sure what I'm doing.
That's all right.
Do you need something?
I don't know.
Okay.
I can't remember why I just came here.
Well, you can come in and have a conversation. We're talking about integration.
Oh, I forgot my phone, and
Yeah, that has nothing to do with
phone?
integration.
You're welcome to
I know,
borrow
it's
mine.